Okay, let's see if I can nerf sword this thing over at the SCP Foundation. Go ahead. It's basically
We'd like to thank NordVPN for supporting PBS. The discovery of the Higgs boson 10 years ago at the Large Hadron Collider was the culmination of decades of work and the collaboration of thousands of brilliant and passionate people. It was the final piece needed to confirm the standard model of particle physics as that model now stands. But there are still many outstanding questions. For example, it seems like nothing in the standard model can explain what dark matter is.
I would put that thing in
So
orbit,
the discovery of the
and I'm
Higgs
going to put
wasn't
that
the
thing
end of
through
particle
that
physics,
glove. You understand?
but it may be the way forward.
Both.
Many physicists think that the secret to finding the elusive dark matter particle will come by studying
You're
the
going to need that
Higgs.
here in a minute.
In
This
fact, the
trigonometry.
first tantalizing evidence is already in.
It's really important. Size, inner diameter, outer diameter, high, low.
The matter that we perceive out there in the universe is a small fraction of the matter that
here,
exists.
you're gonna need to,
we see and
once you
feel
know what it is,
the
and this
atoms,
is
the
secant,
electrons,
you'll know
and the
prime
quarks
for
via
it
the
is a
protons
code
and
because
neutrons.
I'm running out
These
of space
particles
and
dominate our
start
experience of
drawing
the universe
theta, and it
because
doesn't
they are
look right no
strongly
more, and it
interacting.
becomes
They tug and
hieroglyphic,
push at
what's
each other
called
via
force
the
of gravity.
electromagnetic and
Very
strong
big.
nuclear forces.
It's out there between
But
chemistry
there are other
and
matter particles
how much
that
molar
interact
mass
only
is,
weakly. And so we don't see
why
them even though they're insanely
the
abundant.
form that it's
Roughly
in
100 trillion
is
neutrinos emitted by the sun pass through your body
similar
every
triangles.
second. But you don't notice them because
notice
they
them.
rarely interact with the electrons and the quarks
the way
that make up the
that this
atoms
would-
that make up you.
Hold on.
And then there's
This
dark
is what
matter.
actually happened.
We know that there's some source of
let's call
gravity
it.
out there in the universe not caused
Not
by
making it
particles of the
270,
standard model.
negative 273
We see its
Kelvin,
effect in the
which
way
is
galaxies move
bad.
and how the universe on the largest scales evolves. This dark matter might
so
be a new kind of particle.
gauge bosons
in
over
fact,
here.
there could be an entire family of different particles that interact with each other, but not with us.
Braun,
We talked about this so-called dark
Dirac
sector in a
equation,
previous episode.
Einstein's field
So,
theory.
how do you
They'll
go about
help you
detecting a particle whose defining
make
quality
negative-
is being
and then
almost undetectable?
buzz.
Let's start
Buzz.
by looking at how we detect new particles in general. We can bundle the different methods into three broad categories,
It's a calculus
each
class.
represented
That one right
by
there.
a different
You don't know
Feynman
how
diagram.
to make that
A Feynman
not
diagram
a
is
ball.
just a way to represent the interactions
And
of particles.
so as a teacher,
plotting time
I
versus
shot a
space.
photon at
So we
you
have two
with all that
particles coming
perfect
together,
geometry,
undergoing
trig,
some interaction
right?
that
And
involves the
something
exchange
happened.
of
It
force
wasn't
carrying
the
particles.
result
And
on
then
the
we have
dot plot
particles
of
leaving
times
the
or
interaction,
systems
perhaps the
didn't
same that went
necessarily
in,
do
perhaps not.
the
This particular
light
diagram
sound
shows a
squeaky
dark
I'm
matter
looking
particle
for,
scattering
which
off
means
a standard
I
model
don't really
particle
understand
in
the
some way.
trigonometry. The
The standard model
trigonometry to the
particle
results
could be a
that cat
quark,
get in front of
an
that mouse
electron,
on
or
pond there,
anything that makes up normal
inside the
matter.
Gaussian pipes here,
We would call this a
calculus
direct
frames
detection
between
experiment
this
because a
3.145
dark matter
is a
particle has actually
calculation.
interacted with
A
one of the
loop a
particles
computer
in,
has to
say,
go
our
through
detector.
that for
Of
sure
course,
is
this sort of
one
interaction
increment.
is
Now what that one
incredibly rare.
increment is
Otherwise, we'd have
over
detected dark matter particles already.
this,
But with enough particles
that
and enough
makes
time, we should
rotations
eventually see
and
an interaction
then the screw
between
bolts,
a dark matter
plastic,
particle and a
metal,
matter
or how
particle.
long
So
its
dark matter
serviceability
detectors
could be
consist of
what it is, and
huge
fuzzies
tubs
dialing
of
in
liquid or massive chunks of crystal placed deep
the math is
underground
what says
to
it's
avoid
real.
cosmic
All
rays.
these energies doing the same thing
Either
for
our
it
detectors
to
aren't big
trigger a
enough,
little
or we haven't
sensor
waited long enough
at a point in
because we have
time.
yet to spot a single
Is like putting it on a road cone with a
compatible
bunker
with the
buster.
dark
And when
matter
I say
particle
everything is a
hypothesis.
hadron collider,
The second
I mean
family of
negative
experiments,
273 Kelvin.
indirect detection,
This
can be
photon
represented by
hit
rotating
a
our
result.
Feynman
We
diagram.
then
A
back
cool
that up
thing
and
about
reassured
these
it with the
diagrams
science. The
is that
two
if one
experiments
orientation
we
is
had,
possible,
but
then
over
all other
logarithms,
orientations are
I'll
possible.
become a more accelerating
In this case,
frame
the time and space
comparatively to
axes
shooting that
are flipped.
photon at
So now
somebody,
we're looking
getting a
at the
difference
annihilation of a particle-antiparticle
why
pair
that
from the
result
dark
in
sector,
that number
resulting in the
of the black
creation
body
of a
problem, or which type,
particle-antiparticle pair of a known
supermassive,
standard
black
model
hole,
type.
rocky
For example,
body.
two dark matter particles somewhere out there in space could annihilate to produce
supersymmetries,
gamma ray photons, which could be picked up by telescopes like the
are kind of
alpha
particles.
magnetic
I think it's a lot of
spectrometer.
magnetism,
If we were to
but
find
like in the way
excess
the
gamma
large
radiation from
forces
high-density
and the little
regions of our
forces, we
galaxy,
can kind of perceive
then
those
this might
weak
come from
forces because
dark
they're stronger
matter
to us, and it's
annihilations.
inverted.
But
Gravity's
it's very
a negative. You
difficult
got to get through that
disentangle
crypto
this source
and
of gamma
field
rays
theory.
from other astrophysical
They are
sources
going to be using
like
those
pulsars,
symbols,
supernovae,
forms,
and things
equation,
being
gauge
eaten by black holes.
bosons, and if you
So
don't know
far, we
how
have no
to
clear evidence
at least
on this
perceive
method.
how they're
okay, so let's try
utilizing
rotating our Feynman
the gauge
diagram
boson,
one more time.
It'll be a
Now
reaction,
our annihilating dark matter
whether we
particles
like it or not,
become
not of
dark matter that's created
antimatter.
from the annihilation of some standard model particles.
Reflect.
Now,
Or
some
it's on
theorists
a
think that we could
45
see
degree
this by
mirror for
looking
the
at the high
trigonometry,
energy
not
collisions
necessarily
of standard model
anti.
particles
Yeah.
in
It's
collider
in the pipes,
experiments
it's wiggling
like
around,
the
that
LHC.
wobbles.
And this is where our
times
Higgs
it
boson is going to come
does
back
not
into the
negative
picture.
273
At the LHC,
Kelvin.
we smash together
Accuracy.
particles of regular matter, like
I'd have to see
protons
what their
or
accuracy
heavier
limits are,
nuclei.
because we have
All
them.
sorts
That
of
means
exotic
to
particles
a
get created
degree
in those
of
collisions.
Heisenberg's
Those
uncertainty, it's
particles
very
are sometimes
precise.
detected directly when they
Now,
smash into
out of
one of the
odds
many
and probability
detectors
there,
surrounding
you
the
could say
collision
that
point,
number of
or
collisions
they may
is
decay due to being
80% of a
hopelessly
full
unstable,
aspirin to
in which
Tylenol
case we
chemistry
detect their decayed
experiment
products.
bottled into this
But of all the
point
particles
happening,
produced in
that
these
at the
events,
end of it
we
there
think
will be,
that the
after the
elusive Higgs
recrystallization
boson has the
and
best
it's
shot
all
at
dried out,
producing a
that there will
dark
be
matter
that
particle.
result of
Let's
what
talk
the
about why.
gauge
Firstly,
bosons,
particles with
calculus molar
electric
mass,
charge or
plus
color
your
charge
result
can't
logs,
decay
or the
into Higgs
entirety of the
bosons, because the Higgs
multimetrics in
itself
that
doesn't
system
have such
says,
charge. If it
should
did,
put
it would interact
that
by electromagnetism or
mathematical
the strong
result
force, and we would
into
have spotted it already.
that is
So
how
that
it's
excludes
in
the
the
electrically
pipes.
charged leptons, electrons, muons, and tau particles. It excludes the quarks and whatever
And
is
we're
made
pointing
of
down
quarks.
here. This is a
It
Campbell
also
soup
excludes
can
the W boson
on
of
the
the weak
market
nuclear
or the
force.
factory.
It excludes the color-charged gluons of the strong nuclear force.
So
And
there's
we
a few
also
things going
exclude
on there
photons
at a time,
because not interacting with
equally
light
like this.
is
They
the
are
first
frames.
defining
They do that.
characteristic
If
of
there are
dark
some standard
matter.
models to
We
it,
aren't left
and
with
they
much in the
puzzles-
standard model. Neutrinos could potentially decay into dark matter particles, but if they
ever
do,
stand next to a
it's going to
building?
be
No.
near impossible to spot the event. So we'll leave that aside.